Okay. Hello everyone. Okay, so if you read the news, then you should be probably know that several students have been not really infected by the virus, but we need to be careful. So I hope you prepare your mask, and if you want to talk with me, uh, I need also to prepare mask. Okay, so that's the first thing. Hopefully, we don't have any case here. And as our schedule, so we hope we will have the midterm on Wednesday. But if there's something happen, I will let you know before. But uh, the default still on this Wednesday for our midterm. Okay. So for today, actually, I'm preparing some exercise for you. So I hope you can check the exercise. Let me give you a first couple for exercise. Let me write the questions first. For number 2, is it clear? Okay, so you need to find which series that are convergent. It can be more than one. Okay. It's not a single correct answer. It has probably a multiple answer. And also, please wear your mask if you finish. If you finish. Okay. Okay, for the first question, is there any question for the first one? Okay, let me go to in more details for number 1. Okay. Okay, first is you have the circle. R equal half, which means the circle will have the center on the exactly at this origin, and the polar curve cos 2 theta will have 4 leaves like that. Okay. And the area outside circle and inside the 4 leaves, so it should be here, and all the area here. Okay. The first thing you need to do, you need to find the intersections. This is the intersection. Right? And let's find the intersections. So half should be equal cos 2 theta, which means 2 theta should be pi over 3, or in this case, theta is pi over 6. Okay? So in the first quadrant, the theta is pi over 6 here. Okay? Now, because all the leaves will be symmetrical, let me write here. Because leaves symmetry or symmetrical, which means if you have 1 leaves, then you need to multiply with 2, right? But because you have 4, so you need to multiply with 4. 4 and 2. So let me write 4 and multiply by 2, and then integral from 0 to pi over 6. And then let me factorize half outside here. So this will be r squared. The first one is the cos 2 theta squared minus half squared, and then d theta. Okay. And this becomes 4, 0, pi over 6. And this will be cos squared 2 theta, right? And I will change into double angle. The double angle is cos 4 theta over 2 plus half. And then it will be minus with the 1 over 4. And then all with the d theta. Okay. And now let's integral. Cos 4 theta becomes sine 4 theta divided by 4. So should be sine 4 theta divided by 4 and multiply by 2 is 8. And then half minus 1 over 4 is plus 1 over 4. So plus theta over 4 from 0 to pi over 6. And plug in the pi over 6 into the equations. So sine 2 over 3 pi, which is square root of 3 over 2. So it should be and become 16. And it should be pi over 24. And 0 will be make all equation 0. So the results is square root of 3 divided by 4 plus pi over 6. Yes, that's the results. Okay, depends on what kind of questions you will get. I will prepare two type of questions, like the multiple choice and just essay, like 2 parts. So if this type of questions is in the multiple choice, then you need to find until the exact results as in the options. Okay, as you will see in the options. If not, then if you want to stop until here, this one, this is okay. This until this result of the integration, that's okay. But if in the multiple choice, you need to find until here, because I will give you the options. Okay, okay, that's number 1. Number 2, we have 4 options here, and the question is which one of the series is convergent. Any idea? What is the answer? Any idea? Number 2? Okay, let's start to check. Okay, for A, is it converge? A. Why diverge? Mm-hmm. And then? Mm-hmm. Any idea for number A? For A, is it diverge? Okay, so let me write here for A. A is sine 4n divided by 4 with the power of n. Okay, so let's concentrate on this an. Okay, this this. Okay, let's concentrate on this. If I have 1 over, okay, is it greater or smaller? Less, right? Smaller, right? So it's probably smaller, okay? So first, the questions for this one, is it converge or diverge? So let's just checking the ratio test, right? Checking the ratio, it's 1 over 4. So it's less than 1. So it is converged, right? Okay. So if this is converged, then this is the left one, converged, right? Okay. So A is converged. So probably A will going to be our answer. But let's check the other one. Maybe we can find another convergence. Let's check B. So you have ln, and then 1 minus 1 over n. How to check? Okay. So if you ever encounter this type of form or equations, 1 minus something, fractions. So whenever you find 1 minus 1 over n, right, like that, my suggestion is to change the form into this form. So whenever you find any value minus or plus with the fractions, so change it into a whole fractions like this one. So if you have ln, you may change this into ln n minus 1 and then minus ln n. Okay, we are doing this way because if you check the n from 2, 3, 4, and then so on, if you check, let's check ln2, ln with n equal to, it will be ln1 minus ln2, right? Check with n equal 3, so it should be plus, right? ln2 minus ln3, and then check another one, it's become 3 minus ln4. So what kind of sum is this? This is called the telescoping sum. I hope you remember. What telescoping sum means is you are actually like using telescope. So you are shrinking and focusing into the first part and the last part. So the middle part will be canceled, right? Like that. So all this will be canceled. And the last part is just minus ln n, right? Just some random n, right? So this whole sum becomes ln1 minus ln n. Because we need to have limit like that. In divergence test, this is diverged, right? Because it's doesn't equal 0. Okay. So divergent. So B is diverged. So this will be diverged. What about C? Is it converged or diverged? Who says it's diverged? Still not sure? Okay. Whenever you find the equation has a fraction. First, it is a fraction, and it has cosine or sine. The method that I'm suggesting is using comparison test. Using comparison test. Okay. So you have 1 divided by n plus n cosine squared, and this is start from n equal 1. Okay. Now, if you look at this equation, the cosine here, possibly the maximum is just 1, right? So we can compare to this 2n, right? And since this, if you check several n, this will be true, right? Because cosine in between 0 and 1 is a half square of 3, right? In which that, because the cosine is in the numerator, so it will be larger than 2n. Okay, got it? Okay. Now, this 1 over 2n is, of course, it's diverged, right? With p series, okay? With p is just equal 1, so it's diverged, right? So the left one should be diverged, okay? So it's diverged. The last one, d, okay? Let's check d. Is it converged or diverged for d? Okay, I think it's similar to what we have done, I think, last week. So if you have like a square root in your fractions, first thing you need to do is arrange the form. Okay, so we call this method rationalization. So multiply with the other part of these terms. Okay, when we are doing this, then we are getting rid of the square root on the top, and the bottom will be just this. So this is just only 1. Now this is our new form, and we can compare this form with 1 over, imagine this is square root of n and this is square root of n. What will happen? This is 2n, right? Or you can write this as, if you remove the plus 1 on the square root. So we can compare this to 2n, 3 over 2. And this is true, right? This is true. It's less than this 1 over 2n with the power of 3 over 2. Okay. So again, we can use the comparison test. Or if you want, you can use the limit comparison test also. Uh, you can use this limit, and this should be having a positive value, and depends on b. If b is diverged, then a diverged. If b converged, a converged. But we also can just use the direct comparison test. So this is direct comparison test, in which this b is Uh, Converge, right? So this is converge. So the answer having A and D. Okay. Okay, two questions. Let me give you a couple more. Let me give you the other one. Okay, I hope it's clear. Okay, what is the answer for number 1? Okay, if you don't remember how to find the slope, let me remind you. The slope is dy over dx. Okay, and this is precisely dy over d theta divided by dx over d theta. Now x and y is r cosine theta and r sine theta. So dy over d theta becomes dr d theta sine theta plus r cos theta and dr d theta cos theta minus r sine theta. Okay, now we have r is 2 plus sine. So dr d theta is just cosine. So we are using that information to our solution. So cos theta sine theta plus 2 plus sine theta and then cos theta and then cos theta minus 2 plus sine theta and then sine theta. And evaluate at theta is pi over 4. So both of this is half, half, the 2 plus, and this also 2 plus. I will give you the result is negative 1 over square root of 2. Okay. Okay, is it the same as yours? If you have different answer, okay, I hope it's the same, right? Okay, the next question is the interval of convergence. Okay. The interval of convergence of the series, let me write the series. It says ln 1 plus 2 over n, and then x with the power of n. Okay, as usual, using the ratio test. Oh, this is having the square root, sorry. Okay. Okay. And and this 2 and x power of n. Okay, now let's solve this first. So resulting in x, and we can write a limit Okay. Now what we can do, if you see something like this, you check first, plug in n into the equations, and it will be 0/0 situations, right? It's 0/0, 0 and 0, which means you can do the L'Hopital rule for the n. Okay, so L'Hopital rule. So what you need to do is to derive both the top equation and the bottom equation. So derive becomes 1 over 1 plus 2. It's It's too small. Let me write bigger. Okay. And then multiply with the chain rule. It's -1 and plus 1 and -3/2. Same thing at the bottom. And multiply by x. Check the results. Check with the n. I believe this should be equal 1 if you check the infinite sign into the equations. So this will be resulting to be converged, resulting just x. So to be converged, this x should be less than 1, right? Or we can write it down. Okay. And then we need to check. Okay. So first, if you get these results, it's not finished yet. Okay, so let me write here. It's not finished. So I need to check x equal 1 and check equal x -1. So check x equal 1 from our formula. So if you have x equal 1, so it's just ln 1 plus 2. Okay, so let me write here, it become ln 1 plus 2. Okay, which is this is diverge. Okay, which is diverge. And check x -1, and this become converge, right? By alternating series. So the answer will be including -1 but excluding 1. Mm, the most simple way, try several n. You will see it will be diverged. Or you can use um, I think comparison if you want to compare, but with something with ln. But just try some n. You will see it will be diverged. Okay. Okay, let me uh, go for another question for you. Oh, let me change the questions. Oh, I think true. Okay, number one is about the sequence, and you are given by uh, the formula of the sequence, and check which one is true. I think you can have more than one answer. And then number two is checking the series whether it is conditionally convergent. And you have four options. Okay. Your midterm level will be this similar difficulty with all these questions today. Okay. For the first one, I think it's the question is not too difficult, but you need to try to see maybe fitting the options with the questions. Okay, so like a trial and error. So which of the following are true? A, the sequence is increasing. B, it's bounded. C, A2, you need to try, right? And D, limit as an approach infinity is 4. So first is you need to check your so if your A0 is 2 and A1 is 5 minus 4 divided by 2. So it will be 3. Okay. And try A2. This will be 5 minus 4 over 3. And this will be 11 over 3. So our options for C is wrong, right? Of course, it's wrong. Then try A3 is 5 minus 4 over 11.3 is around what? 3. 3, 3, right? Or 3, 4. Or let me just write this 11.3. And if you check A4, A5, you will see that in terms of the answer, the part here, it will be getting closer, 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 right? To 1, right? So you will have, this is around, it's getting closer to 4. It's getting closer to 4, getting closer to 4, getting closer to 4, right? You can check, okay? You can check. And you can just use some simple approach to check a simple value. So all the a n, as n getting bigger, is getting closer to 4. So the first one, an is increasing. Of course, it's increasing from 2, and then 3, and then 4 something, 4 point something, right? So it's increasing. And it's bounded to 4, right? It's getting closer to 4. Okay. And of course, definitions for the bounded is this. So the questions, so for the solution, you have A, B, and D. That's the correct answer. Okay. Okay. The next questions. Which one of the following is conditionally convergent? Okay. So first of all, you need to differentiate what is conditionally convergent. So there is absolute convergent. Let me write here first. And there is conditionally convergent. In alternating series, we learn these two terms, right? What does it mean? So absolute convergent is you have an, let's say an, and you have the absolute. Okay. If both are convergent, so this is converged, then it's absolute convergent. Okay. If you have one is diverged, one is converged, then you can say that's conditionally convergent. Okay. Or otherwise. Now we need to check from all these 4 options, from A, B, C, and D, which one is conditionally convergent. So you need to try to check the series and its absolute value. Okay, let's check number A. Let's check A. Okay, for A, I can rewrite this as this, right? Which means this is, if you are looking at one, the formula or the pattern, if you multiply with -2/3, it will be this. It will be the geometric series, right? So in geometric, the ratio should be less than 1, and it's true, it's converged. Now check the absolute value. It's the same or similar geometric, which is R is 2/3. It's also less than 1. So it's also converged. So both is converged. So this is absolute convergence. Not our answer, right? And what about B? Okay. Now first, look at B. It has -1 and with the power of n. So it obviously it's alternating series, right? And then you have sine and then with pi over n. So in alternating series, you only need two requirements for the series to be converged. Okay. The first one, you need to make sure the series decreasing. Okay, let me write decreasing. You need to make sure for alternating series. Let me write for alternating series. You need to make sure that the series is decreasing. And the second requirement is the limit value for as n approach infinity. This should be 0. And of course, if you are seeing the form, it's true, right? The second one is true. And if you check the sign um, from sine, let's say it's pi/2, and then sine pi/3, it's already decreasing, right? It's already decreasing. Of course, if you add sine pi/6, it's also decreasing. So decreasing is also correct. So we can say by alternating series, this is converged by alternating series. Now we need to check the absolute value for these cases. So we only have sine. Oh, I think we need to start with 5, sorry. So it should be 5. So what we can do now, well, it's 5. Remember that I think in your exercise, we have this. And this is equal 1. So this is by limit comparison test. Okay, so limit comparison test. And we need to check the series of pi/n. And this is all actually our P series, right? And it's diverged. So the sine pi/n diverge, okay, by limit comparison test. So this is diverged, this is converged. So this is conditionally convergent. Conditionally convergent. So this is correct, number B. Yes. Yeah, yeah. Mm-hmm. How, what do you mean? Mm-hmm. Mm. But it's pi over n, not pi n. So it's always decreasing. So the pi will be pi over 1,000, pi over 10,000, pi over 20,000, pi over 1,000,000. It's a fraction. So it will be not having like a 1 minus 1, different. But if you have sine pi n, that will be possible. So let's see the C. This is diverged, right? You can just using the limit for divergence test. So divergence test. So limit and approach infinity of our E. And you have the result, right? It's 1. So it is diverged. Number D. So at some point for number for point for options D, this part it can be 0, right? And of course, if you are looking at the absolute value, this is just the same, right? Nothing seems different. And this converge, and this is absolute converge. So our correct answer is only B. Okay. Let me check another question. Okay, for the first questions, we have the functions x and then multiply with e to the x. And then the questions is the derivative, the 100 derivatives of the functions with x equals 0. This is actually the Maclaurin constant, right? Maclaurin constant. Okay, how to deal with the first one here? So let me write here. Let me write the e to the x in terms of sum. This is our sum for Maclaurin series, right? So if we multiply with x, we multiply also this sum with x, okay? And then it becomes x n plus 1, and then with over n factorial. Okay, let's write down in terms of our formula for the constant of the series. So this will be, let me write k, okay, instead of n to differentiate these two. So f and then k. Okay. So when k is 100, so let me write maybe here. So when k is 100, this is actually equal with, so if k is n plus 1, then this will be 1 over 99 factorial. Okay, get it? So f is 100 factorial divided by 99 factorial. It's 100. Okay, if you don't get it, let me go to here. Remember that you can expand this into, let's say this is 1 plus x 1 factorial, right? And then x squared 2 factorial, and so on and so forth. The same thing with here. We can also extend this from x plus x squared one factorial. So the difference is just less one, right? This having x and 1 factorial. This having x squared and 1 factorial. Okay. So whenever you find until 100, so you will have in here, this is x with 100, but in here, because it's plus 1, so it's 100, but this is 99. Get it? So that's why the f100 at x0 is just 100. Okay. Okay, any questions here? Okay, let's go to the second question. Which of the following series is divergent? So let's check one by one. For A, okay. My suggestion, whenever you see power here, power n, or factorial, you can go directly to ratio test. So you can go to ratio test. And this is true that uh, half is less than 1, so it's converged. So this is not our answer. We need to find the diverged one. Okay, it seems alternating series. What we need to do is we need to check whether it's decreasing, or check several n from 0, 1, 2. I think it's decreasing from, let's say, if we are looking at n equal 1, it seems decreasing, right? And then its limit, this is equal 0, right? So it's converged also. For C, this is uh, P series, also converge. So probably D. But let's check D. Anyway, in the exam, if you just find like 3 answer you think it's wrong, then you can just choose the only one answer. Okay? To so you don't need to check if you are already confirmed that the other answer is wrong. So we can write these terms instead of this. Okay. So we rearrange the form. We get this. And then we arrange also becomes like this. And looking at 1 over n as our comparable series, this will be larger, right? You can check several n that has squared, like 4, 9, 16, 25. This is always true, right? And since these terms is diverged, then this will be also diverged. So this is our answer. So B is our answer. Okay. Okay, let me check the other. Okay, let me move to the other page, and maybe this is the last exercise for you. So let's check your understanding from the last previous question. If functions. Okay, for length of the curve, as long as you know the formula for the uh, the length, so you need to just write the formula, and then the rest of the calculations will be just algebra, okay, and integral for the formula. So write down the x. Let's say xt is et cos t. Remember, if you have this equation like this is two functions, right? So you need to do product rule. Okay. Sometimes you are only making just differentiate the cos or t, and then forget the product rule. So if you have this, you need to use the product rule. Okay. So this will be et cos t minus et sin t. And same thing with equation y. And then we are using all this information to our L. Okay, I believe you need to be able to solve this. So it's just that is the answer. Okay. Okay. The last one, if you see this, you can relate to e to the x, right? So let me remind you e to the x. Let me write the whole formula for the constant. Okay. And e with x cubed. We need just to replace x with x cubed and then n. Okay. So let me write the formula. So instead of n, now we have 3n. Okay. And this will be 1 over n. factorial. Okay. So f. Oh, sorry. It's 3n factorial here. So this will be 3n factorial divided by n factorial. So this is the answer. Okay. Okay, so I hope most of the content for the midterm is actually around all these things. Okay, so for the chapter 10, the derivatives, the integrations for parametric and polar, please remember. And for the sequence and series, especially the series, please read the methods for the convergence and divergence, the power series to find the radius, to find the interval of convergence. Okay, that's, I think, will be included. The Maclaurin series. Okay, please also remind to check the concept. I think that's most of the content for midterm. Okay, so I think that's it for today. If you have any questions, please ask, or if you want to ask after the class, also fine. I will upload the notes in the Moodle later.